So welcome everyone. My name is Tom Kane. I'm the director for the AI lab here at the Center for Applied AI. Today is a talk I've been looking forward to myself. Um, First of all, the last Lunch and Learn 2 weeks ago, we pretty much did an overview of Retrieval-Augmented Generation, or RAG, a very popular technique for developing applications, generating proofs of concepts, and otherwise extending the functionality of large language models. So we gave that overview last week. We will start this week. We don't want to assume people made it to that one last week. So we will go ahead and start by kind of giving an overview of RAG, and then we'll move into maybe the main portion of the talk, which is going to be a demonstration of using RAG in an application, or to solve a problem, however you'd like to think about it. But I'm happy to have, once again, our AI engineers, Devin Slonaker and Siddhant Gupta. They will be delivering the talk today. So thanks everybody for spending your lunch 25 or 30 minutes with us. And the only request I have is just make sure that you are on mute while the speakers are talking. So with that said, let's get started. I think I turn it over to you first, Devin, right? Because you're going to be giving the overview and talking about vector embeddings and vector databases, et cetera. So I just want to finish by saying a lot of the work that we have been doing here, we're going to highlight what we've been doing here, but there's a lot of depth behind, what we can talk about in 25 minutes. But anyway, go for it, Devin, all you.
All right, thank you, Tom. So by the way, is my microphone working? New system.
It's a little low.
It's a little low. All right, let's do this. All right, how does this
No,
sound?
good.
All
Sorry.
right, awesome. Sorry? Oh, that was you? All right. All right, cool. So, hey guys, how you doing? I'm Devin, and so I am sure many of you last time were here at Rag Talk, but like Tom said, there are probably a few of you who are new. So we're just going to do a short overview, and I'm going to also show off some tools that we have researched here and ran some benchmarks on, and we think are useful for Reg. So let me share my screen here. And there we go. All right. Am I sharing my screen? Can you guys see the PowerPoint? Tom?
Yep, looks good, Devin. Looks good.
All right, cool. So if I start a slideshow, are you still able to see it?
Indeed.
All right, awesome. All right, cool. So yeah, so this is our demonstration of the use of RAG, but first we're just going to go over a small refresher. So what is RAG? So RAG stands for Retrieval Augmented Generation, and essentially it's a method that improves the performance of LLMs or SLMs by allowing them to take advantage of external information. So RAG allows LLMs to retrieve relevant information on topics from external databases in real time. And the way we do that is through a vector database, which we'll discuss later. So the benefit of this is that a model's knowledge is not always up to date with current information, but with RAG, you can just insert new information in a database and it will be just up to date. So it's kind of nice. And so the impact is that this allows LLMs to generate more accurate and contextually relevant responses to more to hallucinate less. And this also enhances trust, as RAG can also provide the sources as to where it got the information from. So why do we use RAG? So this mitigates the need to retrain a model, because retraining a language model for new information is extremely computationally expensive, and comparatively, RAG is not as computationally expensive and actually saves a lot of time and resources. So this also allows for dynamic access to information, as RAG allows models to access the latest information without retraining, and And it's also extremely easy to integrate. So all you really need is just three things, which we'll discuss here in a moment. But new data sources can be easily integrated without just completely overhauling and retraining the model. And then it also reduces inaccuracies and hallucinations by actually providing information that the model needs for context for certain queries without it having to guess about what it needs to say for certain queries. So there's only really three main core components for RAG, and it's actually quite simple. So you have your large language model, so something like ChatGPT, an embedding model, which converts a query. So, like the quick brown fox jumps over the lazy dog, that converts it into a vector representation or just a stream of numbers that is then stored in a vector database to kind of, and you can kind of think of of a vector database as sort of like a plane or a map that these vectors embeddings are represented on. So, like if we have a three-dimension embedding, you can imagine it's like an XYZ plane in a vector database. So here's kind of like a small diagram as to how RAG works. So you have a knowledge base and you have a query. So your knowledge base, so the user query is uh, is sent to the retrieval process to then be embedded, and then it will go through the knowledge base of what information is currently embedded in the vector database, and it will kind of like find the closest thing in the vector database to retrieve. And then when it finds the closest thing, it will give the user query and the result of the retrieval to the language model, so then the language model can form a relevant response based on your query. So the retrieval process is a user prompts the language model, and then that query is then embedded into its own vector embedding and then sent to the vector database to find the closest relevant document or chunk of data. So after that, it does a similarity search to find the closest thing, and then it takes that thing that's the closest, picks it out, and gives it to the LLM to say, "All right, here's your relevant information. Go." So, and here's kind of a diagram or visualization as to how that works. So the user query goes into an embedding model, which is then used to query the vector database in a similarity search, and then outputs like top like 10, for example, most relevant results. Because in RAG you can have multiple pieces of data extracted at once, multiple relevant pieces of information extracted at once. So then you can have a more relevant response. So you can actually choose how many top responses you want. You get up like 3, 10, 20 even. But um, but yeah, so it's very useful for just extracting relevant information to then give to a model to stay up to date and stay knowledgeable and not hallucinate about certain topics. So around here we did some benchmarks regarding vector databases, embedding models, and language models. And here are kind of like our top 10 in each category that we kind of recommend you might want to take a look at. So starting off with embedding models, it's going to be a lot of numbers, but all you really need to know is top is best, bottom is relatively the worst in the top 10. And I think we benchmarked somewhere around like 30 embedding models. So these are the top 10, and it's pretty great. Embeds per second is how many words or how many documents the embedding model can embed into a vector embedding per second, and seconds per embed is how long it takes to just do one thing. So this would be like your query, for example, right? How long it takes to embed your query. Now, for most people, 0.03 seconds versus 0.04 seconds is probably not that big of a difference. But if someone really needs something that's extremely time sensitive, here you go. So retrieval average. So this is from a website on Hugging Face that sort of lays out a bunch of these different embedding models and has different metrics of measure. One of them is retrieval, one of them is semantic textual similarity. And these are the top two things that you would need for RAG. The biggest of the two is retrieval, because without a good retrieval metric, I mean, you're just not going to be getting relevant documents back. But from what we found here, the best retrieval is actually like the Stella 400 million metric, or 400 million model. But this is sorted based on both the speed and these scores to find kind of like a balance, because you could have something really, really, really good, but dirt slow. Or you could have something extremely fast, but its retrieval sucks. So so the top of the list is kind of like a balance between speed and retrieval and semantic textual similarity. So you can take a look at this for a few seconds, take a screenshot, do whatever, and we'll be posting these results somewhere most likely. So this isn't going away forever. So next is our vector databases. We benchmarked PG Vector, which is a Postgres vector database, Weaviate, Milvus Lite, Qdrant, ChromaDB, and Cassandra. And these are the top 10 vector databases with the indexes that were used and the metric that was used. So the index is essentially how data in the vector database is organized to make the search more efficient. And the metric is just how it takes, how it measures between 2 points to see how closely related they are. So at the top of the list, IVF flat with vector PG with an L2 metric, which is just Euclidean distance. You can kind of think of that similar to like the Pythagorean theorem, is the best in this top 10 list, as it has the most correctness and it has the least, it has the relatively least search time. So again, trying to find that balance between being really correct and having a decently low search time. Again, something could be really fast, but its correctness could be, For example, like PG Vector at hierarchical navigable small worlds index with L2, it has less correctness, but it's also a lot faster. So again, trying to strike the balance, and the top of the balance there is PG Vector. So it's kind of hard to work with if you're going straight for like a vector database, but it's really good performance wise. So last but not least is our small language models. So again, this was sorted by how fast it is, and it's like obedience and correctness metrics. Obedience is essentially like, hey, in one sentence, explain this. If it does like 3 sentences, that's not obedient. And then correctness is like, who's the first president of the United States? And it says George Washington, like that's correct. A lot of these models actually said John Adams, which is kind of funny. But yeah, so we're measuring obedience and correctness as well as how fast it is. And the Quen models by Alibaba are actually really good by being like really small and really fast while also being extremely correct. So now I'm going to hand it off to Siddhant, who is going to show you a demonstration as to how all these things tie together to make a functional RAG application. And as a sort of a side note, you can make a vector database with these small models. It doesn't necessarily have to be ChatGPT. But yeah, so I'm going to unshare my screen, and the spotlight's on you now, Siddhant.
Thank you so much, Devin. Hey guys, I am Siddhant and I'm one of the AI engineers in the lab. And let's go over with what Devin explained. Let me just share my screen. Can't seem to find it. Okay. I hope my screen is visible.
And you are brave, Siddhant, for doing the live demo.
So funny story, I prepared the demo yesterday night and I reran the demo again like 30 minutes before and it broke. The same code, everything same, it broke. I don't know why this happens, but it did broke. So we had 30 minutes to debug the code again and make it working. So it works now. I did not change anything. Hope everything goes well. All right, just a second. Okay, can you see everything and hear me?
Yeah, it looks good. Looks good,
All right.
Siddhant.
So let's go over with demo. And in this demo, I'll be working with ChatGPT, not ChatGPT, but OpenAI's GPT-4o mini. I'll be using APIs and not the models or embedding models or LLM models that Devin mentioned because they are local and we did not have that much time to make everything local and make them work. So I'll be using the APIs. Let's go over. First, in this first line here, we install all the necessary libraries. The first library is OpenAI. Second is ChromaDB, which is the vector database that Devin also mentioned. And third is PyPDF2. It's a PDF parser which will help us retrieve information, parse the information from the PDF that I provided. This second block of code does everything regarding importing. Once we install all the libraries, we have to go ahead and import those. So here, this is an operating system library, and which we did not mention before. And this one is more important, called user data. This is because we need to store my API keys securely so that my API keys are not open in public. This is what you guys also want to do in future if you guys are working with APIs, because it's a sensitive information, and if someone else has your API key, they can bill you like thousands or like tens and thousands of dollars. So that could be bad. This API key is stored inside Google Colab secrets. And if you, this is a Google Colab interface. If you go here on the left on the key icon, here you can see my OpenAI API key, and it's a secret. So I am accessing it from here. Let's go ahead. And okay, so here I'm getting the same API key from the secrets and fetching it for my demo. And now I'm gonna do two demos. First is what results you get before, if you don't use RAG, and what results you get after you use RAG. So here in this first block of code, we generate embeddings. Embeddings, as what Devin mentioned, are chunks of numbers. They're also called vector embeddings on a plane inside a vector database. So they help measure the relative closeness of what the output might seem. Devin mentioned this some time ago as well. So here we can generate embeddings, and the model I'm using is text embedding ADA2. This is not a model that Devin mentioned before, just because it's a API from OpenAI, and we cannot test APIs right now. And so embedding processes are done. My all of the text is converted into embedding here using the text embedding ADA002 model. Now let's query GPT-4. Right now I am using model GPT-4o mini because it's fast, it's cheap, and it has relatively better output than most of the models out there. So I'm using this OpenAI chat completion endpoint because it will complete the chat. There are a lot of different endpoints, but most people use chat completion because it works with almost everything that you want to do. If you want to complete a fill in the blank sentence, or if you wanted to ask questions, you can do that with chat completion endpoint. And this is our role. Our role is user, and the content is prompt that you guys will see at the very end. And in this block, the normal GPT response has been created, and we will see the response later on. But this code will tell us what we get once we do not use RAG. And now let's move on to RAG. So for RAG, we need an important thing, that is the data source. For data source, I am using my resume because I think ChatGPT by default would not know what Siddhant Gupta does or who Siddhant Gupta is. So I am giving it my resume as document source so that it knows who I am. So here we are using the PyPDF2 to okay, so here we are using PyPDF2 to pass the information, and then so that it can convert everything from a normal PDF to parsed PDF. Here we have the ChromaDB client. That ChromaDB client is our database, the vector database that Devin also mentioned before. This is where we are going to store all of our vector embeddings for distance matching. And here we are gonna convert all of our the parsed PDF to small chunks. So what chunks are? Here you can see I have my PDF uploaded, resume underscore siddhantgupta.pdf, which is also on the left hand side, my file storage. So it will destroy my big PDF into small chunks so that it can retrieve those small chunks better when I recall it in future. So this is really helpful because if you make if you make one big chunk, it is kind of hard for the large language model to retrieve. So that's why we break it into small chunks. So once you can see the output here of this code, there are chunk 0, chunk 1, chunk 2, and up to chunk 4. Here we perform the actual RAG. So here we will, this is just the query for RAG. We put in queries from our prompt. The query is our prompt, and the number of results that we want is 2. So if from those 2 results, it will tell us what's the best result that we can get. And here, this is the main part. This is the prompt that we're giving it. The context, if you can see, is my resume, and the question is the query in the next block. So let's ask it, query, what is Siddhant's education according to my resume? So the first would print response without RAG, and the second would print response with RAG. So as you can see here, the first is response without RAG. ChatGPT clearly told me that, hey, I do not have access to your resume or personal documents, so they cannot tell me who Siddhant is. But when we do RAG, response with RAG, it can tell me exactly what my resume says about my education, my University of Maryland, Baltimore County. Let's try to change the question. What is Siddhant's work X? Hope it runs. Yeah, it's running. So as you can see, again, it says, I'm sorry, I cannot access any personal documents for specific files. But after RAG, it can exactly tell me what my work experiences have been. First is the AI engineer at C4AI, and then I was also working as GRA at Laboratory for Physical Sciences. So you can clearly see why we use RAG, because it helps you get personalized information from large language model that by default it wouldn't have. In conclusion, I would say right now everyone should use RAG because it is currently helping almost a lot of businesses. A lot of businesses are going online. They are using AI to scale their businesses. A lot of people can use RAG in their personal stuff. Let's say you want to study for a test, you can feed the large language model with your data set, the study data, and it can tell you what the study data exactly is. So, yep, let me know if you guys have any questions. And this is
Hey,
it for the demo. And we
hey,
will be
Siddhant,
sharing the Google Colab notebook after this as well.
yeah, thanks for that, Siddhant. So in terms of execution, you know, when you make a query when you're using RAG, is there a default to go first look at the vector database? How does the code know which direction to go? Like hit the model first or hit the RAG first?
This is what Devon also explained in his presentation in the diagram. So first you give the context and then the question. Both of them go to the retrieval process. And once the entire context is converted to chunks, and then the prompt is also converted to chunks, and then there is a match between how close the already existing chunks and how close the new query prompt chunks are. There are different metrics for matching the distance. There is Manhattan distance, there is cosine similarity. So you can use any, and once the closest match is found, it gives out the results.
Thanks. And it looks like we have a question in chat, Devin and Siddhant. From a prompt engineering perspective, is there a significant benefit to chunking data semantically? For example, by breaking the data up into one chunk per paragraph, et cetera.
So there has been work going on in this field, but you should try to make a chunk as relatively close as possible. So my information and let's say Tom's information should be in two different chunks and not one chunk and not four chunks, so that it is easy for large language model to match the distance and see all the information possible. But you can try with you can try with thousands of chunks depending upon the size of your data as well. This is an experiment that you have to do to see what works best.
Thanks. And I like this example, Siddhan. It's straightforward. I think it points out that, you know, the relevance, the importance of using RAG, and it's becoming increasingly more important. Now, Devin, well, both of you, both Devin and Siddhan, we've done a lot of proofs of concepts. We've been doing a lot of studying of RAG techniques. What are a couple of other projects that you guys have worked on that may be worthwhile to let the audience know about that utilized RAG?
So in my case, I have worked with, I think a lot of people might here know NIH. So they have something called as a PubMed, which is the biggest source of uh, medical literature. It has it has research papers, clinical trials information, and whatnot. So I made an application which fetches all the information inside the PubMed library, so that if a user searches for something, let's say COVID-19 effects, so all the papers which has COVID-19 effects in it will return will be returned, and you guys can also summarize the papers all together or one by one each. And you can also, if you want to read, you can just click on it and go to the official PubMed page to read the entire paper. So this is particularly helpful for a lot of people who do not have time to read the entire research paper, the 40-page paper, and just want a quick summary of it. uh yep. And
Yeah, that's
we have
good, and
al-
that's a pretty standard and important use case.
That is actually, and this is just one of the use cases. There are thousands of use cases out there that people have yet not figured out. Uh, like, there could be use cases for businesses, schools, universities, and whatnot.
What was the underlying model that you used with that project, Siddhan?
I For that I used Anthropic's Claude 3 Haiku. For this I am using GPT-4o Mini.
And Haiku being the smallest of the uh,
Haiku being the smallest of the model
of
that
the Claude.
Anthropic released, and it's also fast and cheap.
Yeah. And so, Devin, you mentioned it before, and I just wanted the audience to be clear that you've been also working with RAG applications, but always using, I think you're always using small language models, and in some case, pretty darn small language models.
Yeah, so around here, I've been playing around a lot with local models and local things to ensure that we keep things private because my whole area of research around here is to find ways to make AI not only more accessible, but also more secure and more private because I know a lot of people are very wary of AI and AI related tools because of potential privacy concerns. So I've been working around here to make what is typically a task for a large language model like ChatGPT. So like because RAG is very prevalent in the space of large language models, and I'm trying to scale it for local usage in things like small language models. So one of the biggest projects I have around here is making a RAG project that takes in the entire UMBC Training Center um, book of courses and allowing people to kind of ask the model about various courses that we offer here at the training centers, so then they don't have to waste their time like sifting through all these different things on the website trying to find what they're looking for. So they can just ask the model like, hey, do we offer any AI ethics classes? and in the model will just respond back like, yeah, here you go, here's a class, you know, specifically about AI ethics, and it will like lay out like the curriculum, like what it's going to do, and then you know, like how long the class is going to last. So um I've been working on making that entirely local, and it's actually pretty darn quick, relatively speaking. So that's kind of nice, and I hope to improve it based on the results we found in our benchmarks with like the fastest vector databases, the fastest embedding model, and the fastest language models.
And we skipped by Tom's question, and since Tom is a one of our returning speakers, that's a good question. So Tom asked about basically interfacing with spreadsheets using RAG, and whether or not you're aware of any strategies for for uh, splitting up the spreadsheet into chunks for embedding into the database.
Yeah, so we're going to kind of give you guys a little spoiler. Sadant and I are working on a paper right now, or we'll begin working on a paper regarding various RAG techniques. Because what Sadant showed you is just called simple RAG. It's just simple like document in the database, simple retrieval of the document. But there are just various other retrieval processes that one can do with RAG, and one of them involves spreadsheets. So we will be taking a look at that in our paper, and seeing the best way to carry this out. So stay tuned for that paper. I think you'll really enjoy it considering your question. So yeah, I hope that answers it. So we don't have an exact answer for it now, but we should in this upcoming paper, which should be out hopefully soon.
That's a good question, Tom. Thanks. I like it. And then, so the last one we'll take in the interest of time. What's the process of RAG integration with a large language model? How's that achieved for personalized feedback? So that question, Avira, is one that the slides earlier did speak to, but do you Sidan or Devin, you want to just do the quick overview?
Yeah. So
Because it's answered by I think the picture that we have embedded in the talk from earlier.
here, you want me to share my screen? Just kind of show that off again real quick.
Yep.
Yeah. Okay. So let's see here. All right. Can you see my screen again?
Yes.
All right, awesome. So yeah, this is kind of how RAG works. So we have a knowledge base, and we have a user query, and we have the retrieval process, and then the language model. So the user query, knowledge base, the knowledge base being like the vector database of like objects and like in documents, and then the user query being like what the user asks the model. Will go into the retrieval process, and the user query will be embedded into a vector embedding, so a stream of numbers, and will be compared to various points within the vector database to then pull out the most relevant information related to the query. So then the user query and the result from the retrieval process, so the most relevant document, will then be given to the language model for a personalized response. So, so again, kind of an overview. The user prompts the model, which then creates an embedding, which then queries the vector database to then do a similarity search, which then retrieves relevant data. And then after that, the language model generates a response. And this is kind of how the retrieval process works. Kind of explaining what this just said. So,
Right. Yep.
so yeah, I hope that answers your question. Yeah.
And if you want to stop the share, thank you, and I'll go ahead and share. So thanks a lot, guys. I've watched a lot of YouTube videos on RAG, read a lot of Medium articles on RAG, but I think you did a terrific job explaining the how and the why for RAG. So hopefully everyone else here feels the same way. I'll just go ahead and share my screen real quickly. And just say make a couple final thoughts. First of all, again, thank you very much for spending your time with us today, your 30 minutes at lunch. Just wanted to talk a little bit more about what we do here at the Center for Applied AI. What we just did today is we highlighted the AI Lab, so you have a pretty good idea of what the AI Lab does. But we also deliver courses in both short formats, long formats. We have certificate programs, boot camps. Obviously, the Lunchbox series that many of you have been attending for a while, and we just moved our community from Slack over to Discord. I don't know, a couple of weeks ago, and if you want to go ahead and sign up at our Discord, I think Jen put inside the chat a link to join our Discord. But we really encourage you to do that, because that's where we will post the recording. It'll be posted on YouTube, as Jen mentioned, and so look for follow-ups there as well. Our upcoming courses, we have our Foundations of Modern AI, which is, hey, get a good feel for the landscape of AI, and then as well our AI for Leaders, upcoming next month on the 17th and then the 24th of October. So we'd love to see you in that class. And finally, we will be having another Lunch and Learn. We may be taking a brief break from it, but we definitely have November 21st on the schedule. A gentleman who has a company he's been working with called Swept AI, and some neat stuff that small company is doing. So again, thank you very much. Really appreciate your time, and hope to see you here on our next Lunch and Learn. Thanks again, Devin and Siddhant. Everyone have a great day.